table. And first thing we're going to talk about are the different parts of a radical. So a radical, also sometimes called like a square root symbol, because that's what it is. Kind of looks like a division sign with like that little extra line right here. So radicals, also called square root symbols, are these symbols. The number underneath the radical symbol is called your radicand. All right, and that's just helpful to know so that you guys know what I'm talking about. If I say radicand, I'm talking about the number underneath the radical symbol. The little n right here is going to be your index. So normally, what you guys have probably seen up until this point is that there's no little number right here. If there is no index, it's assumed that n equals 2. So if there's no little number here, this is assumed to be a square root symbol. But later, like if you look on the back side of your notes, like we're going to look at cube roots where the index is 3. So you have like a little number to tell you that we're taking the cube root instead of the square root. All right, so questions on the different parts? All right, so the way that this resource kind of teaches simplifying perfect square roots and non-perfect square roots is a little bit different than I would teach it, right? But we'll just fill this in because maybe it might help you the way that they teach it. So first, we're going to list the first 12 perfect squares. So perfect squares are numbers that if you take the square root of them, you get a number that's like not a decimal, right? So that would be 1. So square root of 1 is 1. So that's a perfect square. Next would be 4. The square root of 4 is 2, right? So that's the second perfect square. Then we have 9. The square root of 9 is what? 3. Then we have 16. The square root of 16 is 4. So you see like how it's going 1, 2, 3, 4. Next one would be 5 squared, which is 25. Next one would be 6 squared, which is good. And then keep filling in until you have 12 perfect squares. So I'm going to freeze the screen while you do that. Fill in the rest. So like, what's the square root of 49? 7. Square root of 64. 8. Square root of 81. Good, and then it keeps going. Square root of 100 is square root of 121. Square root of 12. And usually people don't have beyond that memorized, but you know what you can do if you're not sure if something's a perfect square? You can type it in your calculator. So like Desmos is the one that you'll use on the Aspire test. So I'm going to kind of push that one on you. But all calculators have a square root button. You just have to find it. So like on Desmos, you can click this button. So click this little keyboard and click that button. For me, instead of pulling up that keyboard, I'll usually just type in SQRT. And then it turns into a square root symbol, SQRT. And then I'll type in whatever number it is that I'm trying to see is a perfect square root or not. So like 169, square root of that is 13. Super easy, right? But they won't always be perfect squares, which is what we're going to see in the later examples. So if I type in, say, like 165, right, I don't get a whole number. I get a decimal, which that process will be a little bit different for how we simplify those. But if it is a perfect square, then just write down that number. So like in these examples, what's the square root of 81? 9. So it equals 9. That's how you simplify. The square root of 484 is isn't a common one, but again, feel free to use Desmos. What does Desmos tell you is the square root of that? What was it, 484? All right, so Desmos should be telling you that the square root of that is 22. Up here, square root of 484 is 22. Over here, problems like 4, 5, and 6, you see that there's a number outside, right? But is this number an index, like the 18, is it an index? No, an index would be like a little number, right, in like this little nook right here. So what this is implying is like 18 times the square root of 4 is what it's saying. So what's the square root of 4? So it's 18 times 2, which equals what? 36. That's how you would simplify those. Over here, I don't know this perfect square root, so use Desmos for that one. But in number 6, it's negative 5 times the square root of 121. What's the square root of 121? So then when I simplify it, what's negative 5 times 11? Good. And then we even have fractions. So for the fractions, you're basically taking the square root of the top and the bottom. So like square root of 1 and square root of 16. So what's the square root of 1? What's the square root of 16? So then the square root of 1/16 is 1/4. Same thing over here. Take the square root of the top and the bottom. What's the square root of 9? What's the square root of 100? So then that square root would be 3/10. So the ones that I didn't fill in, 3, 5, and 9, do those on your paper. I'll give you about a minute to do those starts. All right, so like, what's the square root of 64? 8. That one's a perfect square. It's on our list. If you didn't know, you can also type it into Desmos. Number 5, it's 3 times the square root of 256. Now that one's not on our list, so you would have to use Desmos or another calculator to find that. What's the square root of 256? And then it's 3 times 16, which is good. And then for number 9, it's a fraction. Take the square root of the top and bottom. That one should be 5/7. So good on that? All right. Now, I'm not a fan of their method for simplifying non-perfect square roots. What they say is basically find like the closest one from your list and then think of the other numbers that multiply to it. I'm not a fan of that. This method has always worked for me, which I'm about to show you. And so we're going to take example 10, the square root of 24. And for all of these, I make a factor tree. So I'm going to break it down to its prime factors. What are two numbers that multiply to 24? 12 and 2. Could I pick other numbers that multiply to 24? Yes. You should still get the same prime factors at the end. So I could have picked 6 and 4, 8 and 3, not 24 and 1, but numbers that multiply to it. If that number is not prime, you need to break it down further. So like, is 12 prime? No, because there's other numbers that multiply to 12 other than 12 and 1. So what could those numbers be? Good. Is 2 prime? Yes. Is 6 prime? No. So we need to break that down. What multiplies to 6? Good. And then over here, the 2 was prime from that one. So once you break it down to its prime factors, so the prime numbers are at the end of our little trees, what we do is look for pairs of the same number. If we're talking about square roots, we're looking for pairs. So do I have a pair of the same numbers?
Yeah.
What is it? I have a pair of 2s. So I'll kind of group those together. And then what are my leftover prime numbers? 2 and 3. Those will get their own section. But like not 12 or 6 because those aren't prime, right? Now I want you to think of that radical symbol as a little jail cell. All right, in order to escape the jail, you need to have a partner. So like this pair of 2s can escape. And for each pair, you would write it once. Since they get to escape, they'll be outside the radical for the jail. The others that did not escape because they don't have a pair of the same numbers will be stuck inside the jail cell or the radical. If you have multiple, you're going to multiply them together. So then if you had to multiply stuff, simplify it. What's 2 times 3?
6.
So then my simplified radical for number 10 is 2 radical 6. That's how you read it. 2 radical 6. I've never found a calculator that like just gave me that. I always had to do it by hand. All right, but I could check in my calculator that the square root of 24 gives me the same decimal as 2 radical 6. And that's how I would check it like on a test. So questions about that? All right, let's do another and then I'll have you try some. So number 48, or square root of 48. That's not a perfect square, is it? No. So I'm going to make a factor tree for that. What are 2 numbers that multiply to 48?
6 and 8.
Good, and there are other options. For 24 and 2, we can definitely do. What 2 numbers multiply to 24? 12 and 2. And we already did the factor tree for 12, so we know 2 times 6. 6 breaks down. 2 times 3. Do I need to break down any other numbers? No. No. So now that we've done that, since we're doing square roots, we're looking for pairs of the same number. Do I have any pairs?
No.
I have 2 pairs of 2s. So those will be written where? On the outside of your radical. And you write it once for each pair. Do I have any leftover prime numbers? I have a leftover 3, so that will go inside because it didn't get to escape. So then if you need to multiply, then multiply. What's 2 times 2? 4. So my answer is 4 radical 3, which is the simplified version of 48, of square root of 40. Question about that? All right, I'll give you a couple to try. Try number 12 and number 15. The square root of 72. All right, I heard 6 radical 2. Any disagreements? All right, that is correct. Earlier, I got a bunch of answers, so good to hear it in this class. Seems like you got it. Just real quick, we'll do the factor tree. What 2 numbers multiply to 72? 9 and 8. 9 breaks down into 8 breaks down into is 4 prime. So that break that down into good. So your prime numbers, look for any pairs of the same number. You have a pair of 2s and a pair of 3s and a leftover 2. All right, if you have pairs, great, you get to escape the radical. Write it once for each pair. 2 times 3 is 6. Any leftovers go inside the radical. Good? Now 175, it might be hard to find numbers that multiply to 175, but I would probably just think of like my divisibility rules. If it ends in a 5 or a 0, I know 5 times the number will give me 175. So 5 times what gives me this? Not 25. Someone put in your calculator. 35. All right, and you could have picked other numbers too, but that would be my thought process. And then keep going. So 35 is not prime. What does 35 break into? 5 and 7. And even if you have a different set of numbers that multiply to it, you should still have 2 5s and a 7 as your prime factors. So the pair of 5s gets to escape, goes outside your radical. Inside, you have that leftover 7. All right, so any questions about that? All right, question? Okay, real quick. So just give me 1 second. Don't pack up yet. Write this down. Let's say that I didn't know one of my perfect squares, like the square root of 64. We know it's 8 because it's on our list, but let's just say I didn't know, and I started making a factor tree. So I would have picked 2 times 32. Maybe I didn't think of 8 times 8 right away. And then what 2 numbers multiply to 32? And then break those down. What multiplies to 8? And then the 4s break down again. So stop hanging up, literally just look at the screen right now. Since it's a square root, I'm looking for pairs, right? So I have a pair of 2s over here, a pair of 2s over here, and another pair of 2s. Do I have any leftovers? If you have no leftovers, that tells you that it's a perfect square. What's 2 times 2 times 2? 8. All right, so that's how you know it's a perfect square, other than just typing it in your calculator. All right, we'll finish the rest of the notes tomorrow. Don't lose them.